In section 7.5, we're talking about solving trig equations, and we're going to simplify and we're going to do a couple different algebra steps that you might not have thought of, but you fully know these. Just putting them into using trig equations. In trig equations, they're true for some values, but not all. Remember our principal values. So if they ask for principal values, we're going to just give you a quick reminder here. Sine goes from negative 90 to 90. Cosine goes from 0 to 180, and the tangents principal values are the same as sines, so they go negative 90 to 90. So those are the angles we're dealing with when they ask for principal values, just as a reminder here. Basically, what this is saying, these are they're true for some values, but not all. So when we get to the end, we get our answer, we better check our answer to make sure it works. And really, you should do that anytime you work with algebra, and I know a lot of you don't. But we should check our answer. And even I'm guilty of that sometimes, not checking my work and checking my answer and make sure it's true. So we're going to do that. So basically it says solve 2 cosine squared x minus 5x plus 2 for the principal values of x. Express your solutions in degrees. Okay. Well, if we think about this, we see a cosine squared and a cosine. Maybe applying some algebra, maybe we'd be able to take a cosine out, except for this guy doesn't have a cosine, so we can't do that. Steps of, we can't take that out. We could change this cosine squared into like a sine squared, but then again we have sine squareds and we can't do anything with that cosine then. That really doesn't end up working out. If we look at this closer, notice I have a variable squared and then just a variable itself, and then I have a constant. And if you remember your algebra days, that means we have a trinomial. Okay, and this is something squared, just that variable itself and a constant. I know you guys have done a problem where it was like back in algebra 2 where it's like x to the fourth plus 5x cubed plus 1, and you substituted in, you said let's make x equal, or x let's make I think you called it, let's make u equal x squared. And so anywhere you saw an x squared, you can plug in u. So in this case I'd have u squared plus 5u plus 1, and this looked a lot better to you because you knew how to factor something like that, and you didn't know how to factor something with a fourth. Well, we're going to do something kind of the similar. We're going to use a substitution in order to solve this. Now I'm going to say, okay, well, instead of it being cosine squared, let's make x equal cosine of x. So anywhere I see a cosine, I can plug in x. So this is going to be 2x squared minus 5x plus 2. And we know how to solve that. I'm going to show you two methods. We can either we can do the substitution method, or sorry, I call it the replacement method, or we can do the quadratic formula. Either way works. Formula. All right, so the replacement method, what I do here when I factor a trinomial that has a coefficient in front of the x squared is I multiply these two numbers right here, the first and the last, and I get 4. So I'm going to figure out the multiples of 4, and they need to add up to be 5. My multiples of 4 are 2 and 2, 1 and 5. I got to read the signs. This sign, since it's a plus sign, means that the signs are the same. This sign then tells me that they're both negative. Sorry, this is a 4 and a 1. Wow. Okay, multiples of 4. That. All right, here you go. And then if this sign was a negative and this sign is a plus, this would tell me if the signs are different, the bigger one is positive, and so forth. You guys have all had that stuff. That was just a quick reminder. Okay, but in this case, I know my signs are the same. They're both negative. Which one adds up to be negative 5? Well, negative 4 and negative 1 do. So here I have 2x squared. And all I'm going to do, why it's called the replacement method, is I'm going to replace this negative 5x with a negative 4x minus x. Would you agree if I add these two together, I get negative 5x? Then another rule, anytime we have 4 terms when we're factoring, that means we group them. So let's group these guys. I can pull out an x, and I can pull out a 2. So let's pull out a 2x, and then I get x minus 2 here. And then here I need to pull something out of this equation, or this parentheses right here, to get it to look the same as this guy. Well, I notice that I have a minus sign here and a plus sign here, but I need this one to be positive and this one to be negative. So what I'm going to do is I'm going to pull a negative 1 out, and I'm going to get x minus 2, which is good. Since these two are the same, we say we pull an x minus 2 out. So we pull it out of the entire equation, we write it on the outside, and what's left over is 2x minus 1. All right, and then just to solve this, all we do is we set both of these equal to 0. X minus 2 equals 0, so x equals 2. And then 2x minus 1 equals 0, so x equals 1/2. Now, we made our substitution right here, so x equals cosine x. So we go back and we substitute back in, so we write cosine of x equals 2 and cosine of x equals 1/2. Well, to solve that, we need to figure out what angle has a ratio of 1/2 and what angle has a ratio, cosine angle has a ratio of 2. We know that cosine cannot be 2. In fact, it cannot be greater than 1 or negative 1. It's between negative 1 and 1. So that can't happen. Figure out which one has a cosine value of 1/2. We can look at our chart, or we can think about our 30, 60, 90 triangle. Square root of 3 and 2. This would be 30 degrees. This would be 60. Cosine would be 60 degrees, has an adjacent and hypotenuse of 2. That's right here. Or 1/2, sorry. So our answer for this one would be 60 degrees, and that's within its principal values from 0 to 180. And we can put that in, plug it in, and check. I'm not going to waste your time, but that works out if I plug it in and check it out. It works. All right. So that's how we solve that problem right there. We could also use a quadratic formula. We know that the quadratic formula works on equations like this. But you might want to know the quadratic formula. You might want to remember that. Remember, it's negative b plus or minus square root of b squared minus 4ac all over 2a. And remember, then we're just dealing with the coefficients, right? So it would be positive 5, because that's b. This is a, and this is c. Plus or minus the square root of b squared, so 25 minus 4 times a, which is 2, times c, which is 2, all over 2 times 2. All right, so this is 25 minus 816. So I have 5 plus or minus the square root of 9 all over 4. Square root of 9 is 3, so 5 plus or minus 3 all over 4. 5 plus 3 divided by 4 is 2. That'd be 8 divided by 4 is 2. And 5 minus 3 is 2 over 4, which is 1/2. Remember, when you're doing the quadratic formula, it's x equals this. It spits out your answer. So x equals that. So x equals 2 and x equals 1/2. And when we said we were substituting in, this now means that cosine equals 1/2. So, and we know that cosine cannot equal 2, so it cancels out. So we say what trig angle has a ratio of 1, cosine ratio 1/2? 60 degrees. We get the same answer. Okay, so those are algebra stuff that you've seen before. Again, some more algebra stuff here. 2 tangent x sine x plus 2 sine x equals tangent x plus 1. None of these are squared on them. I might be able to change this to sine over cosine, but then I have sine squared over cosine, and it's not really getting me anywhere. But what we can do is a typical thing when we're solving algebraically is we want to have all the terms on the same side. We want to have it set equal to 0. So I have 2 tangent x times sine x plus 2 sine x minus tangent x minus 1. And all I did was I brought this over here. Okay. Well, we said it earlier, when we have 4 different terms, I have a tangent x sine x, that's a different term than just sine x, and it's also a different term of just tangent x, and so forth. I have 4 different terms, so why don't we group these guys and see what happens. Here I can pull out a 2 sine x, correct? And when I pull a 2 sine x, I'm left over with tangent x plus 1. Here I need this parentheses to be the same, so we're going to have to pull out a negative 1 to get these both positive, so minus 1. And I get tangent x plus 1, which is good. That's what we want. Now we're going to, since both these are the same, we say we're taking a tangent x plus 1 out, and we write that in its own parentheses, and what's left over we write in its other parentheses. So 2 sine x minus 1 is what was left over. And this is perfect, because now we're just going to solve. We're going to say, okay, tangent of x equals negative 1, and sine of x equals 1/2. And all I did is I set both these guys equal to 0 and solved. Okay? So then we got to figure out the values for tangent of x that makes tangent negative 1. and it has to be within, it didn't say for principal values. I think it's supposed to. It's supposed to say principal values. So that's from negative 90 to 90. Um, tangent equals negative 1 at, I think, is that negative 45 degrees? Yeah. So down here 45 degrees. This would be 1, 1, square root of 2, and this would be negative. If this is 45 degrees, our tangent would be negative 1 over 1, which would be a negative 1. So negative 45 degrees is the answer for that one. And when does sine of x equal 1/2, you can look at your chart, you can do your 30, 60, 90 triangles, and for time reasons, I'm going to tell you that it's 30 degrees. You guys know how to figure that out. We've been through that before. So our two answers are negative 45 and 30 degrees. All right. And if we were trying to solve these for all values of x, oh, it does say for all values of x. My bad. Okay. Well, okay. So this is a tangent function. It has a period of 80. This is like what we've done in the past. So for negative 45 plus 180k is all values, no matter what. Sine equals 1/2 at 30, and sine has a thing of a period of 360, so plus 360k. And if that's true, then we got to keep going. Sine also equals 1/2 over in this quadrant over here, which is 150. So it'd be 150 plus 360k also makes this true. Okay. So these are, I guess, are all the answers. I guess I should have read my problem a little better for all values of x, not principal values. I was wrong. Okay. So if they say all values, you got to find all values. If they find principal values, just stay within your principal values. I'm going a little fast here because I'm trying to make this video as fast as we can. Okay. So solve sine squared x plus cosine 2x minus x, or cosine x equals 0 for the principal values. For this one, I notice I have a sine squared. I can do some things with that. I might be able to change it to a cosine or something like that. I have a minus cosine x over here. One thing I might do is I might look at my chart here, and I might look at what can I do with this 2x here, because that thing right there isn't like these other ones. It doesn't have an x by itself. So if we can at all, we want to get rid of these double angle formulas. So let's look at the double angle formula. All right. And let's see, I got to find the double angle formulas. Double angle formula. So for cosine 2 theta, I have three choices. I can go 2 times cosine squared minus 1, or I can go 1 minus 2 sine squared, or I can go cosine squared minus sine squared. And really, I don't think it matters. Let's pick one and go with it. So I'm going to go with, let's see, I'm going to say sine squared x. This is a sine squared, so I'm going to make this one into a 1 minus 2 sine squared. Let's try that. Minus cosine squared, cosine x equals 0. These are both sine squareds. I can add these together. It leaves me over with a negative, so I would have 1 minus sine squared x minus cosine squared x, or minus cosine x, and that equals 0. 1 minus sine squared x is actually a Pythagorean identity, and that equals cosine squared x. And when I get to this point, wow, I notice that I can take a cosine out, take cosine x out, and I'm left over with cosine x minus 1 on the inside. And then again, I just set both of these guys equal to 0. So when does cosine of x equal 0? It equals 0 at, it's for the principal values. Cosine is from 0 to 180. So it equals 0 at 90 degrees, and that's it in the principal values. All right. And then it says cosine equal, when is cosine equal to 1? Well, it equals 1 at 0 degrees for its principal value. So 0 and 90 degrees are answers. And again, you're going to want to check those for time purposes. They do work out. Okay. I think I have one more for you here. And this is a good one. It shows you something that you may not have thought of before. It says cosine x equals 1 plus sine x. Now, we can't really do any changing in this with our trig identities here, because look, most of these are sine squared, tangent squared, all these things are squared, so we can't do too much with it when it's just a regular cosine and a regular sine. One option that we do have, and it's definitely a legal step in algebra as long as we do it to both sides, is we can square both sides. If I square both sides, it's a legal step as long as I do it to both things. This becomes cosine squared, and this becomes, let's FOIL this thing out. If I FOIL this out, I have this one squared, which is 1. Multiply these two and double it, so plus 2 sine x, and then square this term, plus sine squared x. And now let's try to solve from there. All right. I know that cosine squared x, we can make this 1 minus sine squared x. And from here, let's get everything to the same side. We'll factor in all that fun stuff that we've already done before. So let's add sine x, sine squared x, add these two. So now I have 2 sine squared x. I'm going to subtract 1. I'm going to subtract 1, and those let's cancel out, I guess. Plus 2 sine x equals 0. Again, we can pull a sine of x out, so 0 equals, I can pull a 2 sine of x out. 2 sine of x times sine of x plus 1. And then we set both these guys equal to 0. So when I set both of these guys equal to 0, I get sine of x equals 0, or 2 sine of x equals 0, and sine of x plus 1 equals 0, or sine of x equals negative 1. Here I'm going to divide by 2 to get sine of x by itself. And I have sine of x equals 0. So we got to solve for between 0 and 360. All right. When does sine equal 0? Well, it equals 0 at 0 because that's where it starts out at. And it also equals it at, well, we don't have to go to 360. It says less than 360, not at 360. So zeros are only fit there. And here sine equals negative 1 equals negative 1 at 270. And this sine also equals 0 at 180. If we go through and check all these guys, actually 180 doesn't work out. Cosine of 180 is negative 1. Sine of 180 is 0, plus 1 is 1. That does not work out, so 180 is not a solution. That's why we need to check our answers, and 0 and 270 is our solutions. Sorry this is so long. I tried to hurry as best I could. I hope this helps. We'll see you in class.